Hello guys, I'm explaining about nodal analysis. So by using nodal analysis, you can find node voltages. So in my previous video, I have explained about nodal analysis and how to solve the problem. Now this is problem number 3. So now we need to determine the voltage at each node for the given circuit. Now what is our procedure? So here you can apply nodal analysis for planar or non-planar circuit as well. This is our point number 1. And next thing, in order to get equations, you need to apply what? KCL at each node. Therefore, you will get KCL equations. Now, once if you get the equations, what you have to do? You need to apply Cramer's rule, and you will get what? Node voltages from that equations. Now, how many equations you will get? The number of equations is equal to number of nodes minus 1. So if you have 3 nodes, 3 minus 1, and 2 equations you will get, and that means 2 node voltages you will find by using Cramer's rule, V1 and V2. Now see here, this is the given circuit, and what we need to assume first we need to identify how many nodes we have. Here nodes means what? Not a simple node, principal node. 2 or more elements are connected in a common place. Now see here, they have already given, so V1, V2, V3, they have 3 nodes and 1 reference node. Now why they have considered this is node V1? Because see 10 ohm, 5 ohm, 3 ohm and 3 ohm are connected here. Therefore this is one node and they have considered V1. Now this is another node. Why they have considered this is the another node? See 5 ampere, 3 ohm and 3 ohm and 2 ohm are connected here. This is node number 2. Now this is another node. Why they have considered here? 2 ohm, 1 ohm and 6 ohm are connected here. This is node 3. Therefore V1, V2, V3, and we have one reference node, that is V reference equal to 0. In any one circuit, we have one reference node, that one we have to consider as 0. Now what you need to do? Apply KCL at V1. So before apply KCL at V1, what we need to do? We need to assume that current is leaving from that node to the each branch. From this node, this current is leaving I1, and from this node current is leaving towards 5 ohm, this is I2, and here I3, and this is what? I4. Clear. Now if I apply KCL at V1, I can write I1 plus I2 plus I3 plus I4 equal to 0. Now you know, right, as per Ohm's law, I equal to what? V by R. You need to find what are the voltages here in the numerator for I1, I2, I3, I4. Now see, I1 means what? So I already explained how to find I1 in this point, right? So I1 equal to what? One terminal V1 is connected, and this is what? With reference to 0, minus 0, and another terminal, see 10 volt, the source is connected. This is minus 10 by what is the resistance value here? 10. Plus what about I2? So one terminal, one side V1 is connected, and 5 ohm resistor, another terminal V reference, that is 0, is connected by 5. Now here I3 means what? One side V1 is connected, so with reference to what? 0, therefore minus 0, and another side of the 3 ohm resistor is V2 is connected, minus V2 by what? 3 ohm. Now what about I4? One side V1 is connected, minus reference is 0, minus another side of this 3 ohm is connected, V2. Therefore V2 by what is the resistance? 3 equal to 0. Now from this you can write what? V1 minus 10 by 10, sorry, V1 minus 10 by 10 plus V1 by 5 plus V1 minus V2 by 3 plus V1 minus V2 by 3 equal to what? 0. Now what is the LCM here? 10 into 5, 50, 50 into 3, 150. So here LCM is what? 150. If I write LCM 150 here, what happened? 10 ones and 10 15s. Therefore 15 V1 minus 15 into 10, 150. Okay. So here if I write 150 here, 5 30s. Okay. Therefore plus 30 V1 plus, so if I write 150 here, 3 50s, right? So this is what? 50. So plus 50 V1 minus 50 V2, and at the same time here also you will get the same thing. So 50 V1 minus 50 V2 and equal to 0. Clear. Now if you solve this one, you will get what? 145 V1 minus 100 V2, just for time saving, I am directly writing the final equation, okay, equal to 150. Now, if you solve that above one, you get this is the equation 1. Now, if I apply KCL where at 2 node V2, then see, before apply KCL at node V2, what should I do? I should consider current is leaving. I already consider until I4, this is I5, and here this is I6, and this is I7, and here this is what, I8. Now if I apply KCL at V2, I can write I5 plus I6 plus I7 plus I8 equal to 0. Clear. Now what is I5 here? V2, another side with reference to 0 minus another side of this 3 ohm is V1 is connected, V1 by what? 3 plus I6 means what? This current source. Now your assumed current source, current direction is opposite to current source direction. Therefore, you will write minus what? Not plus, minus 5. And plus, what about I7 here? One side V2 is connected with reference to 0. Another side of the 2 ohm is connected what? Minus V3. V3 by 2. Now see, I8 means what? One side V2 is connected with reference to 0 minus another side of the 3 ohm is connected V1. Therefore, V1 by what? 3 equal to 0. Now, what is LCM here? 3 into 2, 6. Okay, now if you put the 6 here, what happened? So 3 ones and 3 twos. Therefore, 2V2 minus 2V1 minus 6 into 5, 30 plus, if I write 6 here, 2 ones and 2 threes. Therefore, 3V2 minus 3V3 plus, if I write 6 here, then 3 ones and 3 twos. Therefore, 2V2 minus 2V1 equal to 0. Now, if you solve this equation, you will get what? Minus 4V1 and plus 7V2 and minus 3V3 equal to 30. Okay, this is our equation 2. Now, what you have to do, you need to apply KCL at V3. Okay, now before apply KCL at V3, what you need to do? You need to assume the current direction here. Okay, now I'll change the color. See here, for V3, how many branches are connected? 3 branches, 2 ohm, 1 ohm and 6 ohm. Now I already considered until I8. Therefore, let us consider I9. Current is flowing here towards the 6 ohm. Then this is I10. Okay, and here in the 2 ohm, let us consider this is I11. So once if I apply KCL at V3, I can write what? I9 plus I10 plus I11 equal to 0. Clear? 1 minute. Yes. Now see, can I find I9? Of course, one side V3 is connected, another side with reference to 0 minus. So you don't have what? Nothing. Another no voltage is connected. Therefore, V3 by 6 plus what about I10? One side V3 is connected with reference to 0 by 1. And what about I11? One side V3 is connected with reference to 0 minus another side V2 is connected. Therefore, V2 by what? You can write 2 equal to 0. Now, what is the LCM here? So, it's 6. Now, if you do this LCM, so here LCM is what? 6. Therefore, you will write V3 my plus here 6V3 minus, if I write 6 here, 2 ones and 2 threes. Therefore, this is what? Plus 3V3 and minus 3V2 equal to what? 0. Now, if you solve this one, finally you get what? The equation 3. The equation 3 is what? I am writing here 0V1 minus 3V2, okay, and plus 10V3 equal to 0. This is my equation 3. Now see, if you apply KCL, you get equation 1, and after applying KCL at node 2, you get equation 2, and after applying KCL at node 3, you get equation 3. Now by using these 3 equations, we have to find V1, V2, V3. Okay, in order to find V1, V2, V3, what we need to do? We need to apply what? Cramer's rule. Okay, you need to apply Cramer's rule. Now see here, I'm writing these 3 equations here. So the first equation 145 V1 minus 100 V2 equal to 150. This is our equation 1. And equation 2 is minus 4V1 plus 7V2 minus 3V3 equal to 30. This is our second equation. And third equation is what? 0V1 minus 3V2 plus 10V3 equal to 0. So what analysis we need to apply here? We need to apply Cramer's rule. So if you don't know how to find V1, V2, V3 from these three linear equations using Cramer's rule, I strongly recommend you to watch how to find V1, V2 for 2 by 2 matrix, how to find V1, V2, V3 for 3 by 3 matrix using Cramer's rule. Okay, I already uploaded that video. Now see here, you can find V1 equal to what? Delta V1 by delta, and V2 equal to what? Delta V2 by delta, and for V3 equal to what? Delta V3 by delta. So once if you know determinant of delta, delta V1, delta V2, delta V3, it is very easy to find what? V1, V2, V3. Now how to write delta? So you can write delta V1, V2, V3 from equation 1 and V1, V2, V3 from equation 2, same as from equation 3 as. Now here what is the V1 coefficient from equation 1? 145, and V2 coefficient minus 100, V3 coefficient is 0. Now from equation 2, what is V1 coefficient? Minus 4, and V2 coefficient 7, and V3 coefficient minus 3. And now V1 coefficient is 0 from equation 3, V2 coefficient minus 3, and V3 coefficient is 10. Now if you find the determinant of delta, you will get 4845. Okay. Now delta V1, what you have to do? Instead of V1 terms, what are the V1 terms? This 145 minus 40. Instead of this V1 terms, you need to write constant values from 1 to 3. So what are the constant values from equation 1? 150, equation 2 30, equation 3 0. The remaining things are same it's like a delta. So minus 100, 0, 7, minus 3, and 10. So once if you find the determinant of delta V1, you will get 39,150. This is what the determinant of delta V1. Now delta V2, what you will write? Instead of V2 terms, now these are the V2 terms. Instead of V2 terms, you will write the constant values. What are the constant values? 150, 30, and 0. Now V1 values and V3 values are same from equation 1 to 3. So what are the V1 value? 145 minus 4, 0, and here 0, minus 3, and 10. So the determinant of delta V2 is what? So 49,500. So the delta V3 you can write. So instead of V3 terms, you will write the constant values. What are the constant values? 150, 30, and 0. Now V1 and V2 terms are same as delta. Okay, 145 minus 100. So minus 4 and 7, 0, minus 3. So once if you find the determinant of delta V3, you will get 14,850. So you already know delta V1 by delta. So if you submit here delta V1 determinant and delta, you will get V1 equal to so 8.08 volts. This is what a node voltage V1. So this is node voltage V1. Now if you submit V2, what? Delta V2 by delta. You already know the determinant of delta V2 and you already know determinant of delta. Then if you submit here, you will get what? 10.2 volt. Now for V3, delta V3 by delta. If you submit the determinant of these two, you will get V3 equal to 3.06 volt. Now see here what we found here. So by using Cramer's rule from equation 1 to 3, you can find the V1 node voltage, V2 node voltage, and V3 node voltage. So here if you don't know how to find the determinant of delta V1, delta V2, delta V3, I strongly recommend you to watch that video, how to find V1, V2 for 2 by 2, how to find V1, V2, V3 for 3 by 3 matrix. Okay, clear. Now see, I'm going to explain one more time what I have did here. So this is the circuit, given circuit, and you need to find node voltage. So first thing you need to identify how many nodes we have. So we have 3 principal nodes and one reference node, total 4. So how many equations you will get? E equal to 4 minus 1, 3 equations you will get. Now we need to apply KCL at V1, KCL at V2, KCL at V3. So before apply KCL, what we need to consider? Current is leaving to the each branch from that node. Therefore, I1, I2, I3, I4. So for V2, we need to consider after that I5, I6, I7, I8 like that. So here finally I get what? 3 equations. By using Cramer's rule, I find node voltages. Once if you know the node voltages, you can find current flowing at 5 ohm. So if I want to find what is the current at this particular 5 ohm, how to find? So current at 5 ohm equal to V1 minus 0 by 5. So you already know node voltage V1. If you submit here by 5, you will find what? 5 ohm. Suppose if you want to find current flowing at 6 ohm, what you do? So equal to here, this is node voltage is what? V3. So therefore V3, the reference is what? 0 by 6. Okay, by 6. So you already know what is V3 and you know 6 resistance value. Then you can find current flowing at 6 ohm. Like that you can find any branch current using these node voltages. Okay, I hope this concept is clear to you. Thank you.